Hello everyone, I am Shiva. This is a small demonstration of my master's project. The basic idea is to test the teleoperation of a Franka arm using a digital twin. To do that, the hand motion of a human hand is captured using the ObjectTrack 3D motion capture system, and the required parameters collected are utilized to map the exact movement on to the simulated robot, specifically placed in a gazebo world. For this project, I developed a ROS package called Franka Teleop. Inside the ROS package, I have 3 ROS nodes. One is for collecting the data and utilizing the specific parameters to map or to transform the coordinates from ObjectTrack world to the gazebo world. The second node is for the testing and calibration of the transformation metrics, and that is developed, or that is actually collecting the data, and the data is visualized in the RVs. The third node is for controlling of the Franka arm inside the gazebo world, or basically the teleoperation or the simulation of the teleoperation in the gazebo world. I will explain each of them as I go through the demonstration. So initially we are spawning the Franka arm inside the gazebo world using the ROS launch. As you can see, now you can see the Franka arm in the gazebo world in the initial position. Next, we will be interfacing the gazebo with the movie planners so that we can provide the values to plan the trajectory of the motion for the Franka arm. Next, we open the RVS GUI and set up the Franka arm as well as the TF, so that the Franka as well as the movement of the teleoperation can be visualized in the RVs. I'm removing few of the parameters or few of the elements of the TF so that the visualization is much more simple. Next, we will be running the teleoperation node so that the data will be collected from the ObjectTrack 3D motion capture system, and from that the values in the required parameters will be collected and transformed and sent as a ROS topic, which can be visualized in the RVs. So that is shown as this one, the teleoperated object, and then you can see that it doesn't change the panda in the gazebo world, as it is only the visualization. So once the visualization is perfect as well as the calibration of the metrics is perfect, we can move on to the direct control of the Franka arm in the gazebo world, and that is shown here. So basically the data from the teleoperated node, or the data placed in the ROS topic from the teleoperated node, will be collected by this third ROS node that I developed, and utilizing that position and orientation data, the inverse kinematics values will be calculated, and then using that values we can execute the commands to the Franka arm. And I'm also showing the package I developed as the Panda Teleop, and I will be uploading this as a GitHub repository or a public GitHub repository soon after further developments. Thank you for your time.